Hello, good evening and welcome. I'm Paul Johnson. We're here, that's today, and this is the title of my talk, Modernising a Legacy Perl Application. I'm going to talk a little bit about how we work with old code. And there's a picture of old code, which maybe brings back some memories to a few of us. Okay, so as Julie Andrews said, let's start at the very beginning, and this is a little bit from, actually, let me get rid of my cursor. No, not that corner. Okay, this is from Perl Hist, and so we can see that, I think as Daniel was mentioning, that Perl is almost 30 years old now, nearly as old as me, and version 1 was released in 1987.
Almost Christmas.
By Larry. yeah, exactly. It was Christmas, yeah. I don't think that's Larry. But that is Sawyer. He is the current Perl release manager, or the Pumpkin, as he's known, which I imagine is his excuse for that outrageous suit and tie. As you can see, Sawyer is trendy. Therefore, by extension, Perl is trendy. And me using the word trendy probably tells you that I'm not trendy. I was thinking maybe I should use the word cool or hip, but that's probably even worse. But the point is that Perl has a number of cutting-edge features, even for a language so old, and a number of features which are in vogue as well. So let's look at a few of the things that Perl is. Perl is succinct. Yesterday we were hearing about Java having a lot of template and stuff. You can do a lot in a little code in Perl. Maybe it's not succinct enough for Damien yet, but that can be fixed, right? Which brings us on to the second point, that Perl is powerful. It lets you do what you want to do. Whether or not that's a good thing or a bad thing is open to discussion in how you use it. See also Damien. Perl has objects. Now, the internal objects are kind of weak, but Moose is a pretty decent object-oriented system, very powerful, has all sorts of goodies, introspection and traits and all sorts of other goodness that you might need. Maybe it's still not quite good enough. Yesterday Damien showed us how to make it better. Unicode. When I was going over this in my head, I wanted to say that Perl's Unicode is second to none. And I suppose that's true, but maybe Perl 5's Unicode is second to Perl 6's Unicode. But even so, I'm not sure there's any widely used languages that have better Unicode support than Perl 5 does. CPAN is pretty much the jewel in Perl's crown. Modules for just about anything that you want, often written by people who know much better than you do. Often not, but that's the way it works. Yeah, there's all sorts of tools. This afternoon Lee's going to be talking about NYT Prof, which is a really good profiler that Perl has. 15 years ago or so, some fool thought it might be fun to write a coverage tool for Perl, and I still think that's pretty much one of the best coverage tools for any language that we have. And also Perl's pretty much, it's fun to work with. If you do it right, Perl's fun to work with, and that's kind of important to a lot of us, I think. It's nice to enjoy what you do. Okay. Those of you at the front can see down the bottom, I've got 38 slides and 40 minutes, which is just about 1 a minute, and I'm not doing very well at the moment, but we'll skip over a few at the end. So Perl is old and Perl is trendy. So there's consequences to this, and basically what that means is there's a lot of old Perl code that's out in the wild, and it's doing stuff, and how many people have had to maintain other people's code? Pretty much everyone, right? Yeah. So we all know basically what this is about, and the code is out there. It's just working. Perl is pretty good at getting things just going and whipping them up, and then it's also quite forgiving about the way things are programmed. So sometimes it's not quite right, but it's still basically working and producing some sort of value for a company, presumably. And sometimes it's our job to keep that going. But then also, because it's basically working, new features are required. We have to do extra work, and that we have to try and build this on top of these very dodgy foundations, and that's quite a challenge sometimes. And so that's pretty much what I want to be talking about today. So there's a whole bunch of problems that we might come across when we're trying to work with this sort of code. Now, perhaps it might have been developed to fairly low engineering standards, talking about architecture, maybe the code itself. Perhaps that might even have been a conscious decision, business decision. I'm not sure that's always the right thing, but sometimes that's the way it is. In any case, a lot of the code we work with is maybe not up to a level that we might hope it would be. There's often little or no documentation, sometimes even worse, the documentation that we have is wrong. There's not always tests. And this is a problem because when you've got a code base that you don't really understand and there's no tests, then you're loath to go in and start changing bits of code because you've got no idea what effect they're going to have on the rest of the system. So this also shows itself in varying styles in the code, because as different programmers over the years have come in and worked on bits, everyone's had the same problem. No one wants to go and change some bit of code to do it a little bit different, because you don't know what else you're going to break by doing that. So a developer will come in and maybe cut and paste a bit of code and probably change a little bit so it's not quite the same, or maybe just write a completely new routine to do something the same or similar, and often in a different style. Duplicated code is the result of that. Maybe the tools and the methodologies which are being used by the code aren't the kind of things that we might want to use. So for example, in the code I'm currently working on, I think there are 4 templating systems in there. I think there's Template Toolkit, HTML template, and 2 homegrown ones, because people don't want to use other things. Probably someone's invented half of their own ORM, and that's sitting there somewhere. And probably the original developers are gone, or perhaps even worse, maybe they haven't gone. Okay, so there's a bunch of problems, and what we were really interested in is solutions. So I'm special. I just noticed I have a purple noose, and yours is red. Does anyone else have a purple one? Ah, okay.
Those are the special ones.
Okay, a few of us are special. Okay, all right. Because I'm special, you're going to get my opinions today. So some of them you'll agree with, and some you won't. That's good. Hopefully, just a bit of food for thought about various bits and pieces. And it's of course it's going to be related to bits of code that I've worked on and my experiences. But hopefully, some of it's interesting to a certain extent. Okay, here's my big takeaway from this presentation. Standardize. Standardize what? Everything. Everything you can standardize it. Why? Well, so as humans, as developers, as humans, there's only so much we can keep in our short-term memory. I think on average about 7 pieces of information we keep short-term. Some people a bit more, as we get a bit older, maybe a little bit less. So the point is, we don't want to fill up that memory that we have, our short-term memory, with irrelevancies. When we're trying to solve a problem, we don't want to be thinking about how am I supposed to get data out of the database in this bit of the code, or what templating system am I using right now. We want to concentrate on the actual problem that we have. And part of the reason for that is because, of course, we get interrupted as the day goes on. And maybe some of you have seen this cartoon from Jason Harris. I don't know if you can all see that at the back. Basically, the poor programmer here is looking at a bit of code, getting it into their head, converting it to meaning, looking at a wider picture, more and more information about the whole system coming into place as this problem is being solved. And then the colleague comes by, hey, I just sent you an email about that thing, and the whole mental model disappears, and he's back trying to work out from first principles again what's going on. So my takeaway from that is this enormous thing here. We want to keep that simple. The mental model we want to keep simple. We don't want irrelevancies in there. We just want the important parts. This quote from Tannenbaum. The nice thing about standards is you have so many to choose from, and I normally try and pick a fairly relevant picture. I don't suppose anyone knows why this picture might be a little bit relevant. It's maybe an obscure jam single, and the B-side is called Standards, so that's why that one's there. But the takeaway from this one is from Tamla Motown, or Martha Reeves and the Vandellas, actually. It doesn't matter what you wear, just as long as you are there. And I'm not going to sing it. But the point is, just choose something, standardise on something. It's obviously try and choose the best you can, but much better to have a standard that you're working with, even if everyone doesn't fully appreciate it, than it is to have different types of different ways of working with the code. So here's my first big one: move to Git. Yeah, seriously, just do it now. It's when I first came to my new work, they weren't able to release the software. It was in Subversion, and on the master branch there was some code that needed to be released, and there was some stuff that shouldn't be released, and no one could make a release because it was all intertwined. So we migrated to Git. Put the stuff on the master branch that should be released, put the rest of the stuff on the development branch, merged them later, made the release, and yeah, nowadays it's just so, if you're working on anything of reasonable size, you need a decent revision control system. Lots of people complain about it, or in my experience they do, because they know Subversion, and Git doesn't map well to Subversion. It's you try and do something in Subversion with the command pull or whatever, and it does something completely different in Git, and then everyone gets all upset about it. But yeah, teach them and ignore the screams. Just get it done. In order to work with an old system, you need the flexibility to have different branches and to have them doing different things, and to merge them and to cherry pick and what have you. And but because Git's so flexible, you need to establish guidelines for its use so that you can keep everything in check. Pre-commit scripts are really useful. Write them and give them to everyone. Make sure they install them so that when they do something wrong, that they know before it gets committed. And teach everyone to write proper commit messages. It all sounds easy, but it's ideal. But yeah, we move in the right direction. Hopefully, whenever we just move in the right direction, we're happy, right? Aha. So we're in a French-speaking part of the country, so I suppose we can quote Jean-Paul Sartre. Hell is other people. L'enfer c'est les autres. Is that it? Yeah. But as developers, we often think hell is other people's code. We don't want to work with other people's code. We'd much rather write our own stuff, right? This is a cartoon from Abstruse Goose, just about someone going through and just wondering what on earth this code is, following it through and trying to find out what's going on. I'll put my slides on my website shortly, so those of you at the back who can't see it can look at that later. Okay, so we spend, I mean, your mileage may vary on here, but we spend a lot of our time just trying to understand code, some time modifying it, and a little bit of time writing new code. Yeah, ideally it's sort of almost inverse, but often it's not, right? So one of the problems initially maybe is just finding out which code is being run. When someone says, oh, there's a bug when I do this, where on earth is it in the code base I have to work on? I like to use log messages with stack traces to try and trace my way through. If you're in Git, then git grep is excellent. And if you're not, or even if you still are, RG is another grep tool, a recursive grep thing that's really fast and very good. Tags files helpful to be able to jump to routines as you move your way around the code. Perl, of course, is dynamic, so we have dynamic method calls, dynamically created methods. So sometimes grep fails because the method you're calling to is defined dynamically somehow with star $x equals sub this, that, and the other. So my tip there is whenever you've got something like that, put a comment there with the names of all the subroutines which could conceivably be defined here, or on the calls, the subroutines that could be called. It's that's really helpful, I found. And configure your environment. I use Git, I use Vim, and so it's set up so I can jump around with tags and grep through things and follow them through on the quick fix list and all this sort of stuff. But whatever your environment, just configure it so you can easily jump around the code. How we do it there. Okay. Right. This is another big takeaway for me, which is to build a core system somewhere with the idea of removing boilerplate. So in practice, for me, this works out as a base module. So this is a module that in every module, in every script, in every bit of Perl code that's written in this project is going to include this module. And it's just going to set up a whole bunch of stuff that's going to be always available everywhere and to save a whole bunch of boilerplate wherever you write it. And just to make sure you don't forget anything and you feel tempted to fall back on some other thing, you've always got everything available there. And so what goes in it? Well, it turns on, I mean, you pick and choose. But for me, it turns on strict and warnings. It turns on features from the newer languages. So if you're using 524 or 526 or whatever, you can turn on the various features that you want. It turns on UTF-8, it imports various CPAN modules, like for example Max that Damien was talking about yesterday not being there. If you put it in your core system and it just is there. A lot of this actually is, over the last couple of days I've been noticing a lot of this is actually making Perl 5 look a bit like Perl 6 is, which maybe is not such a bad thing, I don't know, in a way anyway. Import into is really useful in this. It does all the hard work of taking something that's in a module and importing it into the thing that's using the module. And it's very nicely done. And other things that I stick in there, Moose, Params, Validation Compiler, Try Tiny, List Util, just things that you sort of wish were in the language or that are really useful for your project, and just make sure that they're always available to anyone who's programming in that module without having to think, oh, I need to do a try catch here. Which module should I use? Should I just use an eval? Which syntax? No, you've got try tiny there, you just use it. Here's another one. The last 3 maintenance projects I've come to have had no logging at all. The logging has been print std air and then look in the Apache log. And I don't know, I can't work that way. There's just no way I can work like that. So I create simple logging functions. They're also exported automatically. I call them PT, PD, whatever. Print, trace, debug, info, warning, error, fatal. So you've got the different levels. And they're all very easy. They just take a list of objects or text in between and just print it out to the logger. I tend to use log for Perl and data printer, but choose your poison there, whatever you fancy. Currently integrated with Splunk because that's what the ops team is using where I am at the moment. And also stick it in a Moose role so that it can just be used in any other module that's wanting to do logging, which is basically anything, right? And while we're talking about objects, in my opinion, just use Moose. I think ultimately, if you're in any kind of large system, ultimately at some point you're going to need more power than Moo has or something else. I think Moose is really good, and my suggestion is just to use it. I mean, okay, obviously you choose and pick and choose depending on what's actually happening, but for most things, I would say use Moose nowadays. Use roles, don't use inheritance. Roles are called traits in the rest of the world, and when you start using roles instead of inheritance, so do people know what roles and traits are? Anyone know that? Okay, so basically what this is a way of just sort of bringing in a bunch of functionality into your class without actually inheriting from it, and it solves a number of the problems associated with multiple inheritance. And so if you don't know about that, find out about it, and if you do, just use it pretty much all the time, really, is my suggestion. Also use types as much as possible. So in your Moose class, use types, integer, string, other kind of basic ones, but also you can build up much more complex types. And probably, there'll be a number of types which are relevant to the project that you're working on, the code there. And so create a standard set of types, chuck them in the code that gets exported to everywhere, and they're just available for you. And you can catch so many errors earlier by making sure that the data you put into your objects is of the correct types. In a similar vein, params validation compiler will check when you pass arguments into a function, will check that they match the correct types as well. I've written that in German. Probably with bad grammar, right? No. Nachfolger, was heißt Nachfolger? I think successor. So yeah, params validation compiler is a successor to params validate, and the big advantage over it is that it can use the Moose types, and you already have the Moose types set up. So this is a nice way of working together. Okay, I like this one. A context object. So this is a singleton-ish kind of thing. It's not necessarily a singleton, but is pretty much used as a singleton. It's a repository for any type of information that you need about the context in which the code is being run. That includes the environment. So maybe if it's being run from the web, if it's being run from a script, if it's some kind of job. And it allows you to just get at this information from wherever you are. It also allows you to set up methods without polluting the main namespace. So probably if you've got some useful bit of functionality that you want to be able to use everywhere, chances are if you give it a nice name, that subroutine is probably being used in some other bit of code somewhere else, and you're going to get collisions somewhere. If you stick it onto an object, a singleton object that's exported, then you can overcome those problems. So, for example, I was just, when Damien was giving his last talk, talking about the sub-second or the fractional sleep command. I have one of those in this context object so that you can just call it. And so it's a nice place just to put anything that you easily want to get hold of. Okay, this one's not very interesting. A DB access layer. You've probably got all sorts of bits of code all over the place, accessing the database in all sorts of different ways. So standardize on it. Lots of people like DBIX class. Personally, I've tried a big project with it, and I don't get along with it so well. I spend more time trying to work out how to do some complicated join using DBIX class than just writing the SQL. So my preference personally is I have a low-level class mapping to a table, maybe some additional methods in it. It's a Moose class, so you specify the types of the column, specify the primary keys, add simple methods to work on things. Definitely not a full ORM, just a little layer on top. And I tend to like DBIX simple, but as long as you've got something standard there, just you choose your poison and just use something that makes it easy for you to access the database without having to think too hard, and have all that sort of boilerplate around that DBIX gives you. Sorry, DBI. Dates and times. Probably all over the code there's calls to local time or GM time, and you have to try and remember how many parameters they are and which order they're in and all sorts of stuff like that. Just write a module to deal with it. A local date time module. So the one I've written is based on date time moonpig, which in turn is based on date time. And date time is a large, complex thing. Basically has all the functionality you're going to need. Has a few rough edges though, and these get cleaned up basically with date time moonpig and then whatever I wanted separately on top. The interface is cleaner. Some of the parts of the API are disallowed because they yeah, they can lead to subtle errors. And it makes the datetime object immutable, which is always a good thing, right? Exception objects. Probably all throughout the code, there's all sorts of different ways of dealing with errors. So maybe some function returns false, maybe some returns two values for some return thing and some error code or some error string. Maybe something does a die deep down inside or whatever. There's probably all sorts of different ways. So the way I handle things like that is create a local exception module. Throwable error is quite nice. You can just derive from it. And then this exception, you can override core die or something, so that calling die or logging a fatal error just throws this exception. I mean, you can catch that at some later point. If it's an exception object, you can put all sorts of information in there and just make it nice. It's just a way of standardizing what you're going to do when there's an error. How are we doing for time? Okay. If you've got a particularly large system, you're probably going to need some asynchronous work at some point or another. So a job system is really helpful to do that. It can simplify workflows a lot. So there's a number of, you could use something off CPAN. The work I'm currently doing, I've actually implemented my own for reasons. As a priority queue that allows scheduling, which means that all the cron jobs in the system can be replaced with this queue. Jobs are stored in the DB and listen and notify using select, sleeps and kills. That's because MySQL. And MySQL just doesn't have the nice functionality, or at least 5.6 doesn't. 5.7 is a little bit better, I think, but yeah. Sometimes we have old Perl and we also have MySQL. Double whammy. Okay, config system. So the idea of this is that probably throughout the code there's all these hard-coded values. This thing needs to try 3 times and then error if it fails, or this thing should last for 10 seconds or whatever. The idea here is just to take all the constants and global variables and put them together in a config system, just based on a hash. That maybe also reads these global variables that are probably still sitting in the code somewhere and overrides them or uses them to override. You could put being a Perl hash, you could put subs in there so you can have runtime control of things, so the config system can work out for itself what it's doing based on how it's being run. References back to other parts of the config so you're not repeating yourself all over the place. And local override files for when it's being run in different places. Yeah, it's that's just a nice way to clean up code and put all the bits that can change together in one place. Maybe something that the sysadmins, you can say to them, look, you're allowed to play in here. Leave the code alone, but you can play in here if you want to. This. So often we need to talk to the outside world, and we call system. So you've probably got system calls all over the code. So I was reminded yesterday when Damien was talking about this, the Perl 6 has, what was it, 5 letters, what was it called?
Shell.
Shell, exactly, yeah.
And
shell.
also run.
Okay, all right, okay.
It's better anyway.
Oh, okay. but okay, I don't know the details, but my understanding was that that returns an object with all sorts of information attached to it. And that's exactly what I've created here, the same sort of thing. It's actually based on IPC run, I think, or something similar. Does proper error checking and logging, and it returns an object that collects all sorts of information, standard in, standard out, standard error, return codes, the time it started, the time it ended, whatever else, I don't know. But because otherwise people are just tempted to do backticks, ls, minus l, something or other, and say, no, if you just got this stuff all set up ready just to be used, then you can say to people, no, just go and use that, and you get all the other stuff, and importantly, you get the proper error checking and logging that comes along with it. Get creative, right? So there's probably all sorts of, in each bit of code, there's all sorts of particularly horrible problems. What time do I finish? In 10 minutes, I think, right?
Yeah, 10 minutes.
Okay, right. So one example from the code I'm working on at the moment. one of the programmers wasn't particularly enamoured with objects, and in fact the only use for objects really was returning out-of-band information as the name of the class that the object was blessed into, which is kind of horrible. But otherwise, objects weren't really used. But he liked functional programming, so there's lots of functional programming closures, and a sort of a side effect of that is that so objects are basically data with methods, and functions is the other way around. You have subroutines with data, so you get large amounts of data accumulating, and that data is normally anonymous. It doesn't have a name. So and it gets collected in hashes and arrays. Hashes normally, but this particular programmer liked arrays probably for the 15% speed increase is my guess. So you have these large arrays being passed around, and you get down to some sort of subroutine that's 4 lines long or something, and says, if element 15 is true and element 17 matches the regex in element 3 and blah blah blah, and you think, well, what on earth is element 3 and what's the relations? So you print out this object and you get an array of 40 bits of data, and you think, oh, okay, I have no idea what this is. So one of the things I did was to create a class that I could replace this array with, such that when it was treated as an array, it still behaved as an array, but I could use it as an object and have accesses with proper names for all these bits of data, other methods on there as well. And when I printed it out, it could print out information about what these different bits are. Do we have time? Okay, I haven't got time to show that, but if anyone wants to see that, I can show it to you. And basically, it's just a class with an array as an attribute, and use overload to determine what happens when you treat it like an array. So there's probably all sorts of solutions like that, because Perl is so powerful that you can fit in to solve the problems that you have in your code. Okay, so the code. With the release that comes up in next week today, actually, we'll be replacing System Perl and using CPAN modules. I think most of us know that probably it's better to have our own Perl rather than rely on the system one. If you can only use packaged CPAN modules, then you only have whatever your distribution has, and they're probably a bit out of date, and so you're missing out on the bug fixes and bug fixes, features, support. A good argument for the management types is that I can get 15% extra speed just by compiling without threads. Most of us probably don't use threads.
Is this number actually still accurate?
Oh, I
hear the number a lot, but I think we've moved on to 64-bit systems, which have a lot more registers, and the register is going to be used for the interpreter memory.
It may not be accurate, but it's still a good number to throw because it's written all over the web, right? Okay, this application uses ModPerl, so I had to build ModPerl as well, which is obviously a pain. And Pinto, does anyone know what Pinto is? It's essentially a local CPAN that you can have, and you can put the modules in there, and you can, so when you rebuild things, you can use your local CPAN, and it's all reproducible, which is nice as well.
Just for the record, what exactly do you mean by reproducible builds?
Means that when you build a module and you use CPAN to go and install it, you can point it at your local repo, and you know you're going to get the same version when you build it, even if it's been updated.
Okay, so not that you get the same distribution binary-wise if you rebuild it twice in a row.
Yeah, okay. No, that's not what I mean. No. Okay. Yeah, which is important to packaging systems and stuff, but not so much. Yeah. Okay. I'm not going to spend much time here, but obviously the application should be able to be run locally. The one I'm currently working with, you have to be as root where the package is installed and change things. And you need tests, of course. You need tests. So the code I'm currently working on didn't have any unit tests, but there was a really good reason for that, and that was because it didn't have any units. It's It was composed of sort of 10,000 line long files with 3,000 line long subroutines full of functional bits and that and that. So all the new code is in units with unit tests. I mean, for me that's vital. Selenium for regression testing if you have a web app is really good. And for dev scripts. And the reason for that is so that when you're trying to fix a bug or check something, you don't have to spend all day clicking through the UI to get to the point where you can see whether the bug is still there or whether you fixed it or whatever. Yeah, and without tests you can't do code coverage, and of course that's really important. Right? Continuous integration, yeah, I'm not going to talk much about this, but yeah, just do it. Get a system set up so that when you check something it goes through the CI system, and so you can find your problems as soon as possible. Yeah, I mentioned that this system is on mod Perl. The Apache mod Perl objects gets passed all through to these sorts of subroutines that shouldn't know anything about it. So the context object is my solution to that, to be able to, so these low-level things can ask the context and say, yeah, what was that post parameter or whatever, you know. Plaque is really good. Has a lot of middleware that can help you remove a lot of stuff that's probably in your code. I'll probably go with Dancer too. I haven't done this bit yet, I'm planning on doing it. But Modulicious, lots of people I know like, and yeah, whatever, just use something standardish. And this is really important. Another quote from Tannenbaum: "The only way to make software secure, reliable and fast is to make it small. Fight features." There's probably in a large system there's a bunch of code that's not used somewhere. Find it, remove it. There's probably features that are rarely used or never. Maybe they can go as well. Just try and remove code. And of course the trouble is we need features. So the way as software engineers that we solve this problem is that we decompose. We have smaller problems and we try and have decent APIs between them, and this is really important. And the whole purpose of this is because we want to make life easy for ourselves and enjoyable, right? So standardize everything that's possible so we don't have to keep all this stuff in our heads. Remove special cases because that just kills us really. And I haven't spoken about this, but that's probably another talk altogether. Automate anything that you can. That's it. I've no time now, so I need to give way for Jonathan. But I'm happy to talk to anyone who wants to talk about more details at lunchtime, or I'm here for the rest of the day. And as I say, I'll put these slides up on my webpage, maybe over lunchtime or something, so you can all have a look at the bits if there's anything interesting there. Thank you very much.